All right, hello CS 3140 students. Wanted to take a second and talk about the Huntington-Hill method for apportionment. So the Huntington-Hill method is it was actually written into law in 1929 as to how the United States does apportionment. Previous to that, the United States actually passed a law saying like California had X representatives, Colorado had X representatives, West Virginia had X representatives, so on, so on. And they would derive that like as part of the process of writing the law, but the law didn't state the algorithm. Well, 1929 law for apportionment actually does state it, and so this is the Huntington-Hill method. I have decided to limit this to only states that start with the letter M, just to kind of keep it simple. And for this exercise, I'm just going to say that the total reps is going to be 20. Now, it turns out here you don't actually even need to get a total population or anything. We're going to start by allocating every state exactly one representative. So we have allocated, and I'm just going to make a sum of this column. We've allocated 8 reps, so that means left to allocate is just going to be equal to the total minus that. So we need to allocate 12 more. What we're going to do is we're going to calculate each state's priority. And the priority is a formula that sounds scary, and it's not. It's the population divided by the geometric mean of the number of states the representative has, plus the number of states they would have if they got one more. Or, the number of reps they would have if they got one more. What it actually is just equal to the population divided by, and it's the square root of the number of reps they have times the number of reps they have plus 1. That's it. It's just the number of reps they have, the number of reps they have plus 1, multiply that, and take the square root, and then the numerator in that is just the population. So, oops, didn't mean to do that. So we're going to find the priority for every state, and the state with the highest priority is the state that's going to get the next representative. So, in this case, Massachusetts, not surprisingly, the state with the largest population of this subset, this state is going to get a second representative. So we give them 2. Notice that when I gave them 2, like here's 1, here's 2, doing the optometrist thing, 1, 2. The priority decreased because, of course, now we're not dividing by the square root of 1 times 2. We're dividing by the square root of 2 times 3. And so now the highest priority, if we were to allocate, and we still have 11 left to allocate, is Missouri. Actually, wait, sorry, I made a mistake. Missouri had the highest priority. That was my mistake. So Missouri, in this instance, gets 2. Then Massachusetts gets the second one. And again, notice both their priorities drop. Michigan is the highest priority now, so they get 2. Now the highest priority is Minnesota. Now the highest priority is Missouri again. And then Massachusetts. And now Mississippi. And notice we have 5 left to allocate, but, oops, did I? Yeah, no, I didn't make a mistake there. Montana was that population. Okay. And, now the largest is Michigan again, and now the largest is Maryland. No, not Maryland. Sorry. Hang on. The largest is Missouri again. I have 3 left to allocate. Now it's Maryland, and now it's Michigan. Or sorry, Massachusetts, excuse me. And 1 more left to allocate. The highest is Minnesota. So now we have our representatives allocated. You can see that Maine and Montana both have 1, but Missouri and Massachusetts were the 2 largest populations. They ended up with 4. Michigan, Minnesota weren't far behind. They got 3. Maryland such. I only picked a small number of states just so it's clearly visible. But the point here is that once we're done allocating, we stop. This is the actual procedure used by Congress. If you do it with the 2020 census, you will actually get what Congress is in 2020. So, for example, California, I think, lost 2 representatives compared to what they had prior to this. I know West Virginia went from 3 to 2. New York lost 1 or 2. Texas gained a couple. Florida gained 1 or 2. The point being, the approach here is what Congress uses today. By the way, these population numbers I have, I believe, are from 1900. Just because I dig up a bunch of old examples for this. So this is the Huntington-Hill method. If you have any questions about it, please don't be afraid to ask on Piazza. Always happy to clarify. But I hope for those of you that needed the visual aid, they found this helpful. The advantage of this approach is we don't run into the Alabama paradox that can emerge with the Hamilton approach, where, like, for example, if you stick with the 2020 census, if we had, with the Hamilton approach, Rhode Island only gets 1 representative. With Huntington-Hill, they get 2. With Hamilton, though, if you expand Congress to 436, Rhode Island gets 2 representatives. But if you expand to 437, Rhode Island only gets 1 again. They lose a representative even though Congress gets bigger. That's what we call the Alabama paradox. And that's one of the reasons the Hamilton method is not used anymore. The Huntington-Hill method does have some flaws. In some cases, Huntington-Hill can violate what's called the quota rule. And the quota rule is that, let's say, your expected representatives via taking the population and dividing by the average number of population per representative. Let's say that number were 27.6. If it's 27.6, you would expect the number of representatives that state to get to be 28, rounding up, or 27, rounding down. That would be the quota rule. The problem is, in rare cases with the Huntington-Hill method, and this tends to only happen to states with very large populations, it can round too far. So, like, you could go from 27.01 to having 26 representatives. So you round down past 27. It's rare, but it can happen. The Hamilton approach slightly favors larger states on average over a large sample size. Huntington-Hill very slightly favors smaller states. But not as dramatically as actually the approach that was proposed by Thomas Jefferson, which was used for much of the history of the United States. Anyway, I find that history fun, but this is the basis of the approach, and take care.